You know, there are multiple ways to graph functions, this one being a quadratic function. I'm going to go ahead and do this one more time using the vertex and then ordered pairs on either side of that, but then I'm going to try the x and y intercepts, and then I'm just going to try the y-intercept all by itself to make it a quicker process. So the vertex for this problem is to take the opposite of the b value, which is a -10, and divide that by 2 times the a value. So I have a +10 upstairs and a +10 downstairs. So the vertex of this parabola and what's called the axis of symmetry is where x is 1. And when I put a 1 in here for x, 5 times 1 squared is 5 minus 10 times 1. And then I'll add 7. So again, 1 squared is 1 times 5, which is 5. I'll subtract 10, and then I'm going to add 7. So 5 minus 10 is a -5, and you add 7, and you get the vertex of x is 1, y is 2. I know that this parabola opens like this. I'm going to come back and check that a little bit more thoroughly next. So the value below 1 is 0 and above 1 is 2. The value where x is 0 is called the y-intercept. When you plug in a 0 here for x and you square it, you get nothing, and you multiply that by 5 and you get nothing. And 10 times 0 is nothing. So the y-intercept in a quadratic equation is always this constant right here. So in this problem, when x is 0, y is 7. So it happens that when x is 2, y would be 7. This is a very skinny parabola. When you put a 5 in front of here, remember that's true. And if you have a small number, you have something like a satellite dish. But with a large number in front of x squared, you have kind of a skinny parabola. Here, I'll just prove it to you. So you put a 2 in for x, and you square it, and you get 4. And 4 times 5 is 20. And then you'll take 10 times 2. Well, that'll be a -20, and then you add 7 to it. Well, 20 minus 20 is nothing, and you add 7 to this, and you get 7. When x is 2, y is 7. It'll be pretty hard, probably, for us to put in a 3 and put in a -1, but I'm going to give it a shot, but I'm sure it's going to be off the graph. So I have 5 times 3 squared. 3 squared is 9, and 9 times 5 is 45. Minus 10 times 3, which is 30, so I'm going to subtract 30. That's going to be 15, and then I'm going to add the 7 to it, and I'll get 22 here and 22 here. Pretty tough to put those points on this rectangular coordinate system because it's got to be way off the board. So I am just going to try to draw. Oh, this is not supposed to be a straight line. This is supposed to be somewhat of a curve. Really hard to do. You know, check it on your graphing calculator. Let's clear everything. And so don't forget that you have this as an option. My equation was 5x squared minus 10x plus 7. And I'm, just in case I can't remember, I'm going to go zoom and number 6 for a standard viewing window. And here is that skinny parabola that we just graphed. Don't forget any number of things. You can look at a table of values. So let's see, my table started at a -1. So I'm going to put a -1 in and go in increments of 1 to look and see if my table of values is correct. All right, let's try graphing some more quadratic equations, but let's try using the x and y intercepts. So I'm still going to find the vertex, which is, I'm looking at this problem to see if this is, yeah, okay. The vertex is going to be the opposite of b divided by 2 times a. Well, this is not very nice. This is a -1.5, but that's okay. I'm going to give it a shot. So the vertex is a -3/2 or a -1.5. So when I put that in for x, a -3/2 and square it, I'll get 9/4. And then when I take 3 times a -3/2, I'll get a -9/2. So 9/4 plus a -9/2. So I got to multiply this by 2, top and bottom, to get a common denominator. And now that's a negative 18 over 4. And the 9 over 4 adds to be a negative 9 over 4. Or that's a negative 2 1/4. All right, let's see. I would go to the left 1 1/2 and I'd go down 1 2. So the vertex is about right there at that dot. What would I use next for numbers? Here it suggests that I try using the y and the x-intercepts. I guess I'm going to try that. So the y-intercept is where x is 0. So when you put a 0 in here and square it, you get nothing. And 3 times 0, you get nothing. So it happens to be that the x and the y-intercept for the problem are the exact same value. So I don't really have a choice here. But here's the thing I'd like you to notice. This spot right here, bisecting between -1 and -2 for x, is called the axis of symmetry. So you see this dot right here that is 1 1/2 to the right of that axis of symmetry? I can put another dot right here that's 1 1/2 to the left of the axis of symmetry, and I can sketch this, and this is a little bit easier to sketch a curve for that one. You know, check it on your calculator. You're welcome to find some other ordered pairs. You know, you would be welcome, if this is -3 1/2, you could go something like x is 1 and x is a -2. I think those would both be the same distance away. So x is 1 and x is a -2. Those wouldn't be too bad. 1 squared is 1 plus 3 times 1 is 3. So 1 plus 3 is 4. And a -2 squared is 4. And 3 times a -2 is a -6. And when x is a -2, you get a -2. I've done something wrong there. So let's see. A -2 squared is 4. Plus 3 times that -2 really is a -6. I'm going to pause. You know, I had a -2 here. I meant to use a -4 here because where x is 1 right here, that's a half, 1 1/2, 2 1/2 away from the axis of symmetry. So if I go this way 2 1/2, I'm right here at this spot. That spot right there is where x is a -4. So when I take a -4 and square it, I get 16. And 3 times a -4 is a -12. And 16 and a -12 add to be this 4. So, okay, now I've corrected this. So when x is 1, y is 4. There's an ordered pair. And when x is a -4, so 1, 2, 3, 4, y is a +4. So I was supposed to try to hit those parabolas to go right through there and right through there. Okay. Let's just keep going ahead and addressing the rest. So I'm going to go ahead with the opposite of my b value divided by 2 times my a value, and now I have 5/12 for x. Whew, I think I'm really going to get my calculator out to help myself with this. So just for time's sake, to be honest. So when I take 5/12 and square it and multiply it by 6 and subtract 5 times 5/12 and then subtract 6, I want you to know that I did that with my calculator and I got a -7.04. Hard to graph because x is 5/12 is about a half, and I got to go down about a little bit more than 7. So there's my vertex. This should open up because of the +6. What I did next is I chose to find my y-intercept. So when x is 0, this term is gone, this term is gone, and you're just left with a -6. What I could do next is try when y is 0. You know, doing that means I got to solve by a quadratic equation, and so actually if I did that to set y equal to 0, I have 6x squared minus 5x minus 6. And when I put that into the quadratic formula, I get x is equal to a -2/3 and x is equal to a +3/2. You know, really, in all truthfulness, So again, these are the two x-intercepts when y is equal to 0. So one is 3/2 and one is a negative 2/3. I do have that graphing calculator to help me. So let's just go see though how this works out. Let's plot this point. X is 0, y is a negative 6. Okay, so here's my vertex. There's my y-intercept. One of my x-intercepts, I go to the right 1.5 and y is 0. And the other one, I go to the left a negative 2/3. And y is 0. So you can kind of see this is going to connect. It's really skinny because it's got a 6 in front of the x squared term. And then like this. So again, use a table or use this method. Pretty challenging. I got to tell you, I'm not probably going to ask you to perform on a test by hand. You're going to have that graphing calculator to help you. Just a few more. I'm going to real quick do these. So this one, the vertex, the opposite of b divided by twice a would be a negative 1. So when x is a negative 1, and I put it in here and square it, I get 1. And 2 times a negative 1 is a negative 2. I add 2 to it, I get 0. So I believe I get a positive 1 here. So I go to the left 1 and up 1. This says using the y-intercept. Well, that's where x is 0. So when x is 0, this term's gone, and this term's gone, and you're only left with the 2. So when x is 0, y is 2. Since this is the axis of symmetry, then what I can do is I can put an ordered pair right here to complement that one, and I'm just going to go ahead and draw this parabola with 3 ordered pairs. Good enough. Let's do it again. The opposite of b would be a positive 2 divided by twice a, 2 times a negative 2. 2 over a negative 4 is a negative 1/2. Let me just tell you that when x is a negative 1/2, and I put it in here everywhere I see x, I get y is a negative 5.5. So I'll go to the left a half and down 4, 5.5 right there. I'm going to look for some symmetry here. So I'm going to let x be 0, and then these will be gone. Y will be a negative 6. So if x is 0 and y is a negative 6, I go right here. Yikes. This one's got a negative sign in front of the squared term. So since this is the vertex, the other ordered pair that would work for this is symmetrical to this one would be over here to the left, a negative 1/2. So this is kind of the sketch of that parabola. Again, if I need this for solving an equation or for whatever, I'm going to put it in my graphing calculator. But remember that if I put this into the quadratic formula, this one would have imaginary solutions because it doesn't cross the x-axis. So if you put all these values, a of a negative 2, b of a negative 2, and c of a negative 6, you'd get a negative number under the radical when you solve by the quadratic formula. So finally, let's go ahead and look at this one. And so the opposite of b is 5 all over 2 times a. So that's 5 over a negative 4. And when you put 5 over a negative 4 into that equation, or a negative 1.25 in here and square it and multiply it by a negative 2, etc., you get 25 over 8, which is 3 1/8. So I'm going to go to the left 1.25 and up 3 1/8. Very tough to do by hand. Again, that's why I'd get my graphing calculator out. Then I'll try x is 0. And when 0 is squared and I multiply by 2, I get nothing. And 5 times 0, oh, geez. 0, 0 is both the x and the y-intercept. This one opens down. So this is a negative 1.25 right here. So I've got to go another 1.25. So here's 3/4, and there's a half for a total of a negative 1.25. to the left of this dashed line, and now I can go ahead and connect those dots. Remember, mostly what we use this for is to find solutions to a quadratic equation. So one of the solutions for this one is x is 0, and the other solution for this equation is, I think I said that was a negative 2.5 would work in that equation. So we practiced this a little bit to talk about that again as well, but remember, we can use our graphing calculator.